start recording this lesson. So today we are going to be talking about asteroids and other type of celestial bodies that are in the solar system. So we have talked about the sun, the planets. We've talked about the moon and moon exploration. And now we are going to start talking about what are other things that are out there in the solar system. All right. And if you have any questions, type them there in the chat, or if you have a microphone and would like to interact directly that way with the class, that's perfectly fine. Okay. So have you been to this place? Do you know what this place is that I'm showing here on the screen? Have you seen this before? Let me show you where this is. Okay. So I live here in Utah. Okay. And very often my wife's family is from Arizona. Okay, so we go there to Arizona quite often, and we pass through Flagstaff, which is kind of in the mountains there in the middle of Arizona. And sometimes we go to the Grand Canyon and stop there in the Grand Canyon and so on. But mostly we drive, straight through. And I always notice there's a sign there close to Flagstaff that says Meteor Crater, okay? So many miles, it's like 20 miles from Flagstaff, okay? And so here you have the town of Flagstaff and the road comes this way. And this past summer when we were coming back, I decided, I have to go and see that place, okay? And see if you can spot where the crater is. Okay, we are already at 170 miles altitude. All right, in the camera basically. Okay, can you spot where the crater is? So let's keep focusing. Okay, well the hash mark kind of tags it in. All right, so we are 36 miles above. And see now here, this is the crater that is an impact crater that was created by a meteorite hitting the Earth, right? And this is very interesting because it's not the only meteorite crater, but because this is a very dry area, it is one of the best preserved impact craters, okay? So the crater is about a mile wide from rim to rim, okay? And it's quite deep also. So they have a visitor center here on the side and you can go and visit and they take you on a walk, on excursion here to the rim, and they give you kind of a history of the crater, how it was discovered and everything. One of the interesting things that I learned was that before the scientists actually studied this crater, scientists thought that all craters were made actually from volcanoes, okay? So they thought that this was actually the crater of an ancient volcano, something that came out, okay, from the Earth instead of an impact crater. One of the reasons that they thought that was that there's nothing left of a meteorite or anything like that in here. Part of the reason is because of the erosion, it has kind of backfilled that. And also the other reason is that the impact was such a huge energy, an explosion of energy, that it literally, pulverized the meteorite, okay? So there are remains of the meteorite around the crater, but there's really nothing left of the original one. And not really until the 1940s, 1950s, people didn't know that this was actually an impact crater, not a crater from a volcano. And that actually, the discovery that this was an impact crater changed the way that we view asteroids and meteors, meteorites, and all of that, those things, because before we thought, they don't come to Earth. They don't really land, all right? And if they were, it's not that big of a deal. But the studying this crater gave scientists a lot of other ideas of what could happen, okay, with the impact of meteorites as they collide, and intersect with the Earth. This also gave rise to the theory that probably the Gulf of Mexico, you see here this area, okay, that this area was actually also formed by an impact crater. And now scientists believe that the impact of a meteorite that caused this part of the Gulf of Mexico is probably what caused the extinction of the dinosaurs, anciently, Okay, so these things can happen, not very frequently, but they do happen. So I have a question for you. What is the difference between then asteroids, comets, meteors, meteorites, meteoroids, and all of that? Do you have any idea of what are the differences between those words? Okay. Any ideas? You can unmute yourselves or you can type in the chat. Okay. Is the size or shape, Annika? That is one thing, but it's actually not so much. Let's see. We have meteors. I think burned up in the atmosphere, and one can hit the Earth. Comets are ice and dust, and a meteor is a rock. All right. So let's see if we can make good definitions of these terms. All right. As far as I was reading here, the definition is not very well defined. Okay, to say it one way. All right. So let's say that asteroids are all minor planets, okay? And especially scientists say that are the minor planets that are in the inner solar system, okay? The larger ones have also been called planetoids, okay? So we have that the asteroids normally are these minor planets that are around in space and usually are the ones in the inner solar system. Let me see if I have here this picture. Okay. Hello. All right. Here we have, so if we have the Sun, Mercury, Venus, Earth, Mars, and then Jupiter, so this is the inner solar system. Okay. We have that there is an asteroid belt between the orbit of Mars and Jupiter, lots of asteroids. Then there's lots of asteroids that are inside, okay, closer to the Earth, and those are called near-Earth asteroids. Yeah, this is like the Star Wars, okay, scene there of going through the asteroid field. All right. Even though you can see each dot here, and they are literally millions of these asteroids, they are never that close, okay, like they show in Star Wars. If you were to have them that close, they would probably look more like the rings in Saturn, okay? So where you have really a very dense field of asteroids. Something that I didn't know was that there are also many, many asteroids that are basically moving with the same orbit, in the same orbit or close to the same orbit of Jupiter. Okay? And so the ones Jupiter is moving this way around the sun in this picture, and so the ones that precede Jupiter that are also moving this way, they are called Greeks. Okay? I don't know why, but the scientists decided to call them that way. And then the ones that are about 60 degrees back from Jupiter, they are called Trojans, okay? And as you can imagine, all these things are kind of moving all at the same time. They are all moving following the laws of Newton, okay, the laws of Kepler. Remember when we were studying the laws of motion? So all of these have elliptical orbits, and they are all moving at a specific velocity. Sometimes they collide, most of the times they don't, all right, but there are cases where an asteroid could collide with another or intersect the orbit of one of the planets, okay? So we've seen that the moon has a lot of craters, and those craters are basically created by the impact of asteroids and meteors, okay, on the Earth. All right, so that can happen. So here we have another another picture of some small asteroids that disintegrated in the Earth atmosphere, and this is kind of a picture of what happened between 1994 and 2013. All right. So when an asteroid enters the atmosphere of the Earth and burns in the atmosphere, and you see it as a shooting star, that is called a meteor. Okay. So a meteor. All right. Okay. So yes, I heard about that, about one of you need to tell us more about that, Mac. Okay, so a meteor is when an asteroid starts entering into the Earth's atmosphere, and sometimes we call those also shooting stars. Okay, when we can see them at night. But of course, they also happen during the day. So you see here the ones that are in yellow, okay, kind of orange, those would be the shooting stars during the day that normally we don't see them, except the ones that are very bright, okay? When they are really big, okay, and they explode in the atmosphere, they are also called a bolide, all right? I don't know what is the origin of that. The size of the dot indicates the amount of energy, okay, in gigajoules, okay, the amount of energy that would displace. So the bigger the dot, the more energy that shooting star would have burned as it burned into the atmosphere, okay. Here we have I think that this is one of the biggest dots, one meteorite, okay, meteor that burned up in the atmosphere in Russia last year, and it was during the day, and as it exploded, when it exploded, it caused such really an explosion that broke a lot of glasses. All the glasses on the towns nearby, they broke because of just the impact wave, okay, of that. No one died, nothing hit the Earth, the meteor totally disintegrated in the atmosphere, but there were a lot of people wounded from the glass explosion. Yeah, you remember hearing about that in the news. Yeah. Okay. So that is so we have asteroids is when they are out and about, basically. Okay. When they enter into the atmosphere, they are called meteors. If they burn in the atmosphere, all right, that would be just a disintegrate there. Yeah, I imagine that they are in Russia, especially where it happened. They probably thought that it was an attack or an atomic explosion or something like that. Okay, so if the meteor survives the entry of the atmosphere, then they are called meteorites. Okay, meteorites. Okay, is when they hit the Earth. Okay, so they basically things change name depending on what happens to them. Okay, so we have asteroids is the ones that are just flying around in space. If they enter the atmosphere, they are called a meteor. If they hit the Earth, then they are called a meteorite. Okay, and the meteorite would be the chunk of rock remaining from the meteor. All right, so like this one here, this is a meteorite, the remains of a meteorite in Africa, in Namibia. All right, so big chunks of rocks. I remember.
It looks like a steak.
Yes, it looks like a giant piece of steak. I remember when I was in living in Argentina. Okay, there was a park close by where we were, and they had a natural science museum. And at the door of the museum, they had a huge chunk of a meteorite. It was probably, I don't know, about 1 meter wide and about 75 centimeters, long. And it was a huge piece of metal. It was all metallic, and you can see the intricacies, kind of all the shapes and everything. That those are the shapes as the meteor enters the atmosphere and heats up. It kind of melts, and then when it impacts, of course, it also has a lot of energy release, and that kind of shapes the meteorite in very weird shapes. Does that make sense? So those are what happens. Okay. So let's see. You have Annika. Let's say they build stuff around it. When did they do that? Yeah, I don't know in this one here in Namibia. Hit the Earth. So okay, excellent. So Sam is asking. So how many names? Okay, how many names could a rock go through if it were to hit the Earth from space? Okay. So how many names would it go through? So we have that. If when it's out in space, it would just be an asteroid. Then when it enters the atmosphere, it would be called a meteor. And then when it hits the Earth, it would be called a meteorite. Okay? To further complicate matters, and in the spirit of defining things, we have, so the meteorites are when they hit. So a meteorite, here it says, is a solid piece of debris from such sources as asteroids or comets. Okay? A meteoroid is a small asteroid. Okay? So if it's small, all right, sometimes depending on who you ask, okay, it may have different names, but a meteoroid, if it's about 1 meter big or less, then it's called a meteoroid. It's still an asteroid, okay, but it's very, very small. So those are kind of the definitions. Now, there are some asteroids. Remember that asteroids are the ones going out in space. There are some asteroids that are formed in the outer solar system, okay? And because of that, they are chunks of ice, all right? So very, very cold and condensed pieces of ice. And they are usually in the outer solar system, okay? The thing is that when these asteroids, for some reason, they change trajectory, or because they are, they have a very long period going around the solar system, when they start coming closer to the sun, these chunks of ice and dust, they start heating up, okay? Again, they are coming closer to the sun, the ultraviolet rays of the sun and everything interact with the ball of ice and dust in there, starts heating them up, and then they start kind of igniting, if you wish, the ice and everything starts kind of not just melting, it really literally transforms into plasma. And so it starts shooting kind of a tail of this debris that is kind of getting out from the asteroid, from the frozen asteroid, and then it is called a comet. Okay? So you really have to learn a whole new language as you learn about science. Yes, that is so a big part of science in general for any discipline. Okay, any discipline of science that you want to study, the idea is to study the language and to develop the language. All right? So the comets are these asteroids that have the property that when they come close to the sun, they develop this tail or the coma, okay? And they basically, some of them are large enough and bright enough that you can see them with the naked eye, okay? So a comet means long hair in Greek, okay? So see, you have there, someone was saying it's mostly Latin. There are a lot of scientific names that come actually from Greek, all right? And so a comet is something with long hair. That is the definition of that. So let's see if we have here the article for comet. Okay, all right. Let me do that. Okay, so a comet is an icy solar system body. Okay, and when it heats up, it goes close to the sun, it starts heating up, and then it starts developing the tail. Okay, all right. So that is how the comets form. I remember we have here some pictures of comets. This particular comet is one that is now getting closer to the sun, okay? And yeah, that's right. Yeah, I'm trying to learn some Greek, and I tell you, it's very, very useful. All right. So this comet, 67P Churyumov Gerasimenko. Okay, usually the names are after the names of the people that discovered the comet. This is the comet that just a couple of weeks ago a probe landed on this comet. Okay, you see that as the comets go through this process of orbiting around the sun, they heat up and they form the tail. And some of the material from the comet gets kind of shooted out in the tail, okay? So remember what happens also as the comet goes closer to the sun and it goes orbiting around the sun. Remember when we were talking about Kepler's law of planetary motions? Okay, what happens when they get closer to the sun? What happens to the speed of the comet?
It gets faster.
Excellent, that's right. Yes, it gets a lot faster. Okay, it increases the speed. And so as the comet goes around the sun, it goes faster and then kind of a slingshot back out. Every single time that the comet goes through this period, when it's closer to the sun and is releasing material through the tail, then the comet changes shape and loses material. Eventually, the comet loses all the material that can be ignited and is just an asteroid. It doesn't produce the tail anymore. Okay, so it all depends on how many times and how, it still moves around the sun, but then it won't produce the comet-like tail anymore. So it's not a comet any longer. The hair is gone. Okay, yeah, bye-bye long hair. That's right. So I remember it was when I was in high school, so it was in the 80s, the comet Halley was the last time that went through the Earth, okay? And you could see it actually very clearly on the sky. Mm-hmm. So different comets have different periods. So it all depends really on the periods of that. Okay, let's see if we can see the comet Halley. Let's see what. Let's search that. Okay. Okay, this one is the one that I wanted to see. How Halley? I don't know how to pronounce it. Halley. Okay. So P1 Halley's comet has a period of 76 years. Okay. So I was lucky that I was able to see it. All right. The next time it comes around is in 2061. Okay, so the last time was in 1986. So I was actually, this was after high school. I was in college. Okay, yeah. Mm-hmm. So that's right, Sabrina. So it takes it depends on how long or how much of this material the comet has, and it all depends on the composition of the material, how many times is going to actually remain a comet. Most of the times they remain a comet for a long time. Okay, so Halley, okay, you are yeah, that is kind of close to your name, all right, and so hope you live long enough to see it again. Yes, that is awesome. So yes, I remember seeing the comet Halley as it went through. This is actually a very famous comet because it's quite visible to just to regular times. Okay, and this is recorded as an appearance of the comet in the year 1066. Okay. So in fact, the comet Halley happened to appear in this year, and the interesting thing, the history of this is that this was at the time of William the Conqueror. Okay, and William the Conqueror, he was in Normandy, And let's see if we can go to that area so you can see what is it that I'm talking about. Okay, so let's see, this is a little bit of history, I guess, in the middle of the stuff, but that is good. So William was an heir to the throne of England, and he lived in this area of France, in Normandy, and in the year 1066, part of, because he saw that comet in the sky, he took that as a sign that that was the year when he had to return to England. And so he invaded England and actually conquered England. So the line of kings of England changed at that time, and William was able to conquer England in that year, in the year 1066. Okay, yeah, let's see. The year that the comet is coming again is 1061. All right, let's go back here. Yeah, 2061. Okay, 2061. All right. So you see that these comets have kind of an influence sometimes in history. All right, people interpret the comet in different ways. This is a picture of Halley's comet, the last time that it came around here in our neighborhood, in our vicinity. Okay, so really cool. Yeah. Okay. Yeah, very interesting stories really about these comets. Then let's see, there's another here description. Some people think that the new star, okay, that guided the Magi through, okay, when Christ was born, was probably also a comet, okay. So some people say that it was that the comet Halley, which came 4 years prior to the year 0, was actually the year when Christ was born, and that the Magi were guided by that. So question, how do they know that they are the same one? How do they know that the comet is the same one? Okay, good question, Sam. All right, so from what you have learned so far, maybe it was more brighter then, probably, you know. So probably it was brighter. You know, we know that they lose material, so this has gone several times around. But from what we have already studied about comets, okay, and planets and motions, what do you remember? You know, how do they know that this is the same one? Okay, that Halley's comet is the same one. This is a depiction here of the orbit of Halley's comet. Okay. So one would be the time intervals of appearances. That's right. Okay, so as people record when things happen, if they happen around the same period of time, then there is a suspicion, really, that it's the same object. Okay, we really were not sure of that until, okay, Newton was able to publish in the Principia. Remember the book that we studied when we were studying Newton, and he described there the laws of motion and gravity. Okay. Okay, so you cannot hear me. Is everyone okay? Can you hear me? All right, let's see. Can you hear me? Okay, I can. All right. All right, so Jens, I think that is on your side. Okay. Okay, excellent. So Jens, try to check your audio to see why is it that you cannot hear.
Mr. Ribaldi?
Yes,
I'm remember that if you talk to him in your mic, if he can't hear you, then he can't hear instructions that you're giving him.
That's a good point. Let's type then. Okay. Okay. All right. So yeah, it seems that the problem is there. Okay. So Nathan, what is that will happen in 12 years? Okay, so precise.
Halley's Comet.
In 12 years?
No. In about 12 years, I did a little math on it. The last time it happened was in 1066. I did math from that. I subtracted 2014, that from 2014, and then I did a little bit more math on it, and then it was like 12 point something.
Okay, so the period, remember, of the comet is 75, 76 years, okay? And so the last time it appeared here, it says that it's in 1989, 86. Okay, that's the time I remember. The next time is going to be in 2061. Okay. Yeah, in 2061. All right. So the idea is that now, as we have the laws of motion, of planetary motion from Kepler and from Newton, we can actually measure quite accurately the orbit of these asteroids and the comets and everything by seeing what is the current trajectory and what is the velocity that they have. Remember that all these laws help us to understand through the velocity and the trajectory, we can go and calculate the orbit, and also we can compute the mass of the object. Okay? So all these things can be calculated from the laws of motion that we studied from Kepler and Newton. Very, very interesting thing. Okay. So let's see. Now I would like, so now we have an understanding of the different types of objects out there. So we talk about asteroids. We talk about when asteroids are comets. We talk also that comets, sometimes they become asteroids. Basically, they stop being comets when they don't have any more tail. Okay. We talk about meteors, meteoroids, the small asteroids, and meteorites when they hit the Earth. Okay, so we have all those there. Now, I don't know if you remember in the first lesson we look at a video. In one of the first lessons, there was a video from a scientist called John S. Lewis. He's a member of the church, okay, and he was talking about astronomy and the things that he sees and everything. Okay, so let's see. Haley says, so wait, do all asteroids start as comets? No, they don't, okay? All right, they only the ones that have material, okay, that when they come closer to the sun develop a tail. Okay, so some asteroids, let's see, that is another important thing. Let's see if we can go here to the article on asteroids. So some asteroids they have different types of asteroids. Let me see if okay. So the main types of asteroids are C-type, S-type, and M-type. Okay. So let's see where this takes us. Okay. So a C-type asteroid is a carbonaceous asteroid. So these are the ones that have carbon material. Sometimes they also have water. These asteroids have water. Okay, and we see, let's see the picture here. This seems to be 253 Matilda, a C-type asteroid. Okay, so the C-type asteroids, those are the ones that are more likely, okay, to have to be comets if they have more water content, more ice. Okay, then we have the S-type asteroids, and the S-type asteroids are stony. Okay, so S, C for carbon, S for stony, for stone, and these have different other, types. Okay, so Eros, this one, 433 Eros is an example of a S-type asteroid. Okay, they are more made of silicates and another composition, magnesium silicates. Okay, so it says that they consist mainly of iron and magnesium silicates, and they are dominant in the inner asteroid belt. Okay, so we have several of those. And then we have the M-type asteroids, and these are they are metallic asteroids. Okay, that is where the M comes from. They are metallic asteroids. And so many of the meteorites, the ones that survive all the heat of entering into the atmosphere, are M-type asteroids because they still, keep all that metal, okay, around, all right, and so on. They are made of nickel and iron. Sometimes they also have gold and other rare metals, okay. So there we have the three types of asteroids. So the C asteroids are more likely, the C-type asteroids are more likely just to burn in the atmosphere, to be meteors, okay? The S-type and the M-type, especially the M-type, are the ones that more likely are going to survive the entry from the atmosphere and become meteorites, okay? And the C-type are more likely to be comets if they have water vapor. So it's interesting, one of the largest asteroid in the inner solar system is Ceres, okay? And they have discovered just this past year, it was discovered that Ceres, okay, has actually water vapor in the atmosphere, okay? So here we have kind of a picture of Ceres. You can see that this one is bigger and it's almost all spherical, all round. The smaller they are, the weirder the shape, okay? Because it's harder for them to form into an actual sphere, okay? But see, this one, Ceres, is actually pretty large. So if you have this would be the Earth, the Moon, and Ceres. So Ceres is, quite smaller than the Moon, but it's still quite large. So the picture is kind of blurry, all right? I don't know exactly why, but they have discovered that Ceres has an atmosphere. Now, Ceres is never a comet, even though it has water. It's never a comet because it doesn't get close to the sun. It just keeps in orbit in the asteroid belt. Okay, so it doesn't get close enough in order to heat up. All right, so that is something to remember. Okay, a planetoid are basically any asteroid that is, those are kind of different words and so on. The astronomers kind of discuss and change the vocabulary really. So But planetoids are considered kind of the largest asteroids. Sometimes they are called dwarf planets, and so on, but we can call them all in general asteroids. All the large ones, okay? And we saw what happens with the different types, okay? As I was saying, I don't know if you remember that video from John S. Lewis that he was talking about, astronomy and the study of astronomy. But it's interesting that he has a blog, okay? He also has a Facebook page. And his thing is actually about mining asteroids, okay? So he has written extensively on this idea of mining asteroids, and he published a book called Mining the Sky, all right? So you see, this book is written here by John S. Lewis, okay? And it is an interesting idea, so I don't know that if he's related to C.S. Lewis. He's not related to my family, that is Lewis also, okay? But he lives in Arizona, or at least he lived in Arizona. He was professor in Tucson, Arizona, at the university, and now has joined a company, okay, let's see here, this company called Deep Space Industries. So let's spend a couple of minutes here, see if you can see this video, okay, about this company, okay. Can you see it?
What will tomorrow look like?
Hear it?
Our world is at its limits, and yet we all want more. And why not? Why shouldn't the future be brighter than today? But where will it come from? Simple. Our tiny planet sits in a vast sea of resources, including millions of asteroids bathed in the sun's free energy 24 hours a day.
See the
The same rocks that could fall from our skies also
here.
contain everything we could ever need, both out there and down here. It's time someone seized the opportunity. Deep Space Industries. Deep Space is a new kind of company with a new kind of plan. We don't build rockets, we don't do astronomy. We are explorers and harvesters, makers and suppliers. As they say, timing is everything. And for space, right now is that time. In fact, some of the planet's most successful people are placing their bets on this new frontier. Meanwhile, NASA and others are planning new missions to the Moon and Mars, and new space facilities in free space, joining the billions of dollars worth of communication satellites already in orbit. And as they reach beyond Earth orbit, Deep Space Industries will be there with the fuel, air, and materials they need to succeed and grow. DSI has assembled an international team of well-known experts and young innovators who are building our space legacy and creating new technologies and approaches to open the frontier. We will develop and prove ourselves in 3 areas: exploring and prospecting for asteroids, harvesting and returning asteroid materials, processing those materials for use in space and on Earth. Our early systems will be small and largely off-the-shelf components re-engineered for deep space. We will hitch rides on much larger missions with multiple ways to get into space, where our job really begins. With mission costs so low, we will be able to attract commercial sponsors and build fleets of vehicles to assure our success. Early markets will be satellites in need of fuel, government outposts and commercial facilities, and missions between the Earth and the Moon. As we gain experience and develop our systems, we will grow them as the frontier grows, so that when the time comes, DSI will be ready. We will be the gas station, the oasis for air and water, and the building supply center for the frontier. This is a long game, perhaps the longest ever. While we'll earn our way, the long goal is to create a better future for all of us through space resources. When the first asteroid is mined, deep space will be there. When the first space power plants come online, deep space will be there. When the first space colonies are built, deep space will be there. We can have it all. We can have an amazing future. The resources of space will lead to a renaissance both in space and back here on our precious Mother Earth. We are deep space. The frontier is coming, and our time is now.
Okay. All right, excellent. Okay, let's see. Okay, so you think, Annika, you ask, do you think that this will actually happen? Well, at least Brother Lewis thinks that that is the case. Okay, so he is the chief scientist of Deep Space Industries. All right, so I've actually been trying to reach him, okay, through Facebook. I'm going to see if I can reach him in other ways, okay, and see if we can have him in class. Wouldn't that be great if we could have him here in class and ask him questions and everything? All right. So he is the chief scientist in this organization, in this company. Okay. So Mac, you said not for a long time. Well, you know, it's interesting, but we had 2 weeks ago, we landed the first probe on an asteroid. So the first time that we were actually not just impacting an asteroid, but landed something on an asteroid. Okay, so the idea here is that there are some people that are seriously working on these things in order to use the asteroids and the things that are out there in space in order to get materials. Okay, so yeah, I think that this is actually really, really cool. All right. So Alec and Natalie, are you reading his book? Okay. Are you actually reading Dr. Lewis's book, Mine in the Sky? If you are, let me know how it is. I think that I really would love to read it also. Mm-hmm. Oh, you mean are we supposed to read it for class? No, I haven't assigned that for class, okay? What I would like, I'm going to put in the class for assignments, okay? Maybe reading some of his blogs, all right? So I'll put out there some links to his blogs, all right, and see what you think, okay? So, but that is the interesting thing, okay? The book has actually pretty good reviews, mm-hmm. All right, and I think that it would be very interesting to get his views on deep space exploration and Mine in the Sky, really. Okay, so that is really something interesting. Now, in this side here from NASA, we have this piece of data that it says that about, okay, every day about 100 tons of meteoroids, fragments of dust and gravel, and sometimes even big rocks, enter the Earth's atmosphere. So, you know, most of them we don't see, but it's 100 tons of this space material that enter the atmosphere every day. Okay, so really, really interesting. So most of these never reach the surface; they just disintegrate in the atmosphere, and then they slowly shower down. Okay, but that is a lot of material. So now you know why things get dusty. Okay, and you need to clean up all the time. So that is really one of the reasons. Some people have been afraid of meteorites impacting the Earth, and we have seen that that could happen. Okay, it has happened in the past, and so that could happen also in the future. We've seen it here in the crater in Arizona. Okay, so the Gulf of Mexico and so on. So it could happen again. And so some people are actually thinking of how to use space technology to detect these asteroids that could be meteors and change their orbits before they hit and impact the Earth. Okay, so that would be, many different ways of doing that. In fact, I was listening here to this lecture right before class. I couldn't finish listening the whole thing, but this is a lecture in California that was done last year, and it was about moving asteroids. Okay, what it would take and how would we move asteroids. So, for example, two ways of doing that they explain here. One would be by a kinetic impact, just impacting the asteroid, hitting it, and making such a hit that it would change the orbit, or attaching a tractor, okay, and a gravity tractor to pull the asteroid and slowly, change its orbit, okay, so it would just miss the Earth. And you don't need, again, you can, scientists can calculate all these orbits and when things are going to be around and so on, and so they could also calculate how what it would take to move them. Okay, so things can have a large impact, as we have seen. These meteorites, when they hit, they release a lot of energy. That is one of the things that people believe that happened in the ancient times when the dinosaurs went extinct, was that actually it was a meteorite that hit and caused such an explosion that killed, increased the temperature and change the whole atmosphere of the Earth, that killed all the dinosaurs. Okay, so where are you going to get a tractor beam for that? Well, the idea would be to actually attach, okay, something, to the asteroid and then pull the asteroid. Okay, just slowly. You don't need to move it a whole lot. It's just something to change the orbit, and that would do. Do asteroids orbit planets or just hit them? That is a great question, Annika. Sometimes asteroids become satellites. All right, so if they move around and they get trapped into the gravitational pull of a planet, then they become a satellite. All right, and the main example of that would be the rings of Saturn. So the rings of Saturn are composed of millions and millions of asteroids that are just moving around the planet Saturn. Okay, so the larger the planet, the more likely it is that they are going to harvest, if you wish, satellites around them. Okay, of course that doesn't happen often, because many times they have to hit exactly be close to the planet, but not too close that they would fall onto the planet. Would they spiral inward after a while? It depends. Okay, so for example, when we were studying the moon, I don't know if you remember that actually the moon is moving a little bit away each year from us. So I think, if I remember correctly, that it was about 3 centimeters or something like that the moon is moving away. So the orbit is becoming increasingly larger every year. Okay, so it depends. Sometimes it may get the point where the moon is so far away from the Earth that it would actually escape the gravitational pull of the Earth. So Sometimes they move closer, sometimes they move farther away. Okay? Well, our time has really flown by. Okay? And could they hit an asteroid out of orbit in such a way that they would get close enough to the Earth that we could harvest it? Okay, yeah, that is another idea. So that would be the idea of using an impact, okay, into the asteroid to make it actually fall onto the Earth. The problem is that, depending on the size of the asteroid, you don't know what is going to happen. Is it going to burn up in the sky completely, or where is it going to land? Okay, that would be kind of a tricky thing to predict. Okay, and risky, And if it falls in the ocean, then how do you recover it to harvest it? So I don't know about that. I think that the idea of mining these asteroids is just to be able to get enough material and then somehow bring the material either back to the Earth or use it in other space missions. Okay, use it in space to actually use the material out there. Okay, so for example, one of the things that I was reading is that they were thinking about mining C-type asteroids in order to get water, okay, and to provide water for space missions. Yeah, yeah. You certainly don't want to get an asteroid hitting Earth and wiping out a country. So I imagine that would be a possibility. Sabrina says, what if they could move, the asteroid could be moving orbit around the Earth, okay, so create a satellite and then harvest, okay, the asteroid right there in close proximity, or put a, space station to a new satellite, okay. I guess that could be done, all right. It would be very interesting to ask Dr. Lewis about all these things, really. All right, we have passed our time. Okay, I would like to ask someone for a closing prayer. Okay. Mac, do you have a microphone available that you could give a prayer for us? Would that be okay?
Yeah, okay.
All right. Okay. Thank you.
Dear Heavenly Father, we're thankful for this day. We're thankful for the many blessings you've given us, and thankful for this lesson and the time that Mr. Aboldi put in it for us. And please bless that we may be happy and good, and we may have a good rest of the day today, and receive these things in the name of Jesus Christ. Amen.
Amen. All right. Excellent. If you have another question, okay, you can remain online and ask. All right. If not, we'll see you tomorrow or next week. So who is Stormageddon? Okay. Thank you, guys. Me. Who is me? Okay, the Dark Lord of all. Wow. And Macy, oh, and you wanted to say prayer, Macy. Okay, can you imagine that? I didn't want to ask the Dark Lord of all for prayer. So, thank you guys, and we'll see you next week. All right.